If a car accelerates from rest at a constant rate of 4.6 meters per second squared, how long will it take for the car to reach a velocity of 30 meters per second? So for this equation, we need to use our acceleration equation again. And so if we write that at the top here, A is equal to VF minus VI over T. If I list my variables, I get A and VF for final velocity, VI for initial velocity, and T for time. If I look at the problem, it's accelerating at a constant rate of 4.6 meters per second squared. I'm looking for how long, and we know that how long means time. And I'm going to have a final velocity of 30 meters per second. So if I put some information in here, I know that my acceleration is 4.6 meters per second squared. My final velocity is 30 meters per second. Initial velocity, it says we start at rest here, and anytime we start at rest, we have a velocity of 0 meters per second, and then time is what we're looking for here. So I need to rearrange my equation to solve for time. If I multiply each side by t, I can get t off the bottom. Now my equation looks like A times t, VF minus VI. If I divide each side by A, I can get t all by itself to be t is equal to VF minus VI over A. Now if I plug some variables in to solve for time, time is equal to final velocity of 30 meters per second minus an initial velocity of 0 meters per second, all divided by an acceleration of 4.6 meters per second squared. If I plug things into my calculator in order to solve for t, I get a value of 6.52 seconds.